We are going to split 5.5 into two parts. So today we're doing 5.5a. And we need to remember something about logarithms. 3 squared equals 9 converts into log base 3 of 9 equals 2. Okay? So the other thing we need to know is log base e has a special name. Do you remember what it is? It is the natural log, ln. Okay? So if I had e to the 5th equals x, what would that be in log form? Ln x equals 5. Yep. If I had ln of 5 equals 2y, what would that be in exponent form? E to the 2y equals 5. Okay. So we're going to start solving logarithms. There are only 3 versions of logarithmic equations. Okay. Log base 2 of x equals 3. Log base x of 2 equals 8. Oh, let's not do 8. Let's do 3. And log base 2 of 3 equals x. Okay. The 3 types of equations are put a variable here, put a variable here, or put a variable here. And we need to know how to solve each of these. Well, this one is the easiest. It's already solved, right? Solving equations usually means get x by itself. In that version, x is by itself. So how do I plug that into my calculator? Does my calculator have second gear? No. If I don't have second gear, what do I do? Use 10th gear, and I actually usually use gear E because it's one fewer letter to write. So you could do log 3 divide log 2, or ln 3 divide ln 2. And I almost exclusively use the ln just because when I'm writing it out, that's one fewer letter to write. Okay. So that first one was easy. It's 1.58. Okay. Any questions there? The other two have a similar solution method. How would you solve this one? Yep. Convert to exponent. Yeah. So we convert to exponent. 2 to the 3rd equals x. Oh, that's not an x. 2 to the 3rd is x. And then we just take 2 to the 3rd is 8. Easy enough, right? Okay. This one, we do the same thing. X to the 3rd equals 2. And now I third root it. So x is the 3rd root of 2. Okay? So when you're solving logarithms, if there's an x inside the logarithm somewhere, just convert it to exponent and then solve using your regular rules of algebra. All right. So in your assignment today, 5.5a, this first question says e to the y equals 7. What is that in log form? Would just be the ln of 7 equals y. Super easy. Okay. How would we solve this? 6 to the negative 2 equals x. Yep. 6 squared is 36. The negative flips it upside down. So the answer is 1 over 36. Easy enough. Okay, and then they get a little bit harder. Can I convert to exponent right here? No, I can't. Yeah, I got to get the 5 out of the way. So let's subtract 5. So log base 5 of x minus 9 is equal to 1. Now I convert to exponent. So if there's any fluff around the logarithm, get that to the other side first, and then use the conversion method to solve. So 5 to the first is x minus 9. So x is 14. Yep, not too bad. Now it's going to get tricky. Tricky's good. Oh, same thing here. We got to get rid of everything except the log. So what should I do with that 2? Yep, got to get the 2 to the other side through division. And I have the ln of 4x is equal to 4. Now what? Not divide by 4. So this is an e, right? What do you do when there's a variable inside a logarithm? Convert to exponent. E to the 4th is 4x. Yep. So x is e to the 4th divided by 4. So in your calculator, your e button is usually right above the ln button. So e to the 4th divided by 4, 13.6. Okay. All right, what about this? Well, let's look at something that's a little bit easier. What if I had log of 2x is equal to the log of 10? X is 5, right? How do you know x is 5? But I don't know what log 10 is. Do I care what log 10 is? No. Because I have the exact same logarithm on both sides, the logarithm doesn't even matter. Right? So what do? Do you divide the log? No, that's not right. Do you subtract the log? No. And what we really do in mathematics is we just drop the log. If you have a log base 10 equals the log base 10, then we can just get rid of those. I don't even need them. And you can do that as long as 2 things happen. All you have on each side is a single logarithm and the bases match. So if these were log base 5s, it would still work. But if there's anything else out there, that will not work. So if you have log equals log and the bases match, you just throw them away. So it is the same thing with the ln. Do I have log equals log? I don't know. I haven't solved it yet. Do I have a single log equals a single log? Yeah. Can I manipulate this some way so that I do have log equals log? Well, They have the same basis, so we can use the product rule, right? I have a positive log plus a log, so I'm going to squish these two together. So I get the ln of 3 times x minus 6 equals ln x. Now I can drop the ln's. So 3x minus 18 equals x. Subtract the x. So 2x equals, add the 18. So x is 9. Okay, let's do another one. Okay, oh, I can just drop these, right? Those are already set up. So 2x plus 1 equals 3. Subtract 1 is 2. Divide by 2. X equals 1. Yeah, that one's not bad. Okay, let's find one that is a little harder. Okay. Do I have log equals log? Not yet. But they do have the same bases, so I need to squish these two together. Log base 9 of x minus 1. What do I do with the 2? No. Positive logs go on top. Negative logs go on bottom. So it's just divide 2. Now I drop the logs. So x minus 1 over 2 equals x. That 2 is a problem. Multiply by 2. And I get x minus 1 equals 2x. X is negative 1. Okay. Do you want to do another one? Okay. All right. So this is going to be ln of 2 times x minus 3 equals the ln of x. So I use the product rule to squish those together, drop the ln's. 2x minus 3 equals x. Add the 3. Oh, minus 6. Thank you. Add the 6 and subtract the x. So x is just 6. Okay. Now, you have to be careful, though, because do you remember when we did problems like this? And I squared both sides, and I got x plus 1 equaled 9, and I subtracted 1, and I got x equals 8, and I was really happy with myself until I plugged it in. What happens when I put an 8 there? 8 plus 1 is 9. Is the square root of 9 equal to negative 3? No. So anytime you solve a square root equation, you always have to be careful that the square root is never equal to a negative number. So if we look back at the original problem, can a square root equal negative 3? No. So that would be no solution, right? Well, something similar happens with logarithms. Okay. Let's consider log base 2 of negative 16. 2 to what power is negative 16? So essentially, we're asking this question. Nope. Turns out there's no way to do it. What I'm asking you to do is line up 2's until you get to negative 16. How many positive 2's does it take to create a negative 16? It will never work. So whenever you solve a logarithm problem, you always have to check that you don't create negatives. So what if my answer in this case was x equals 5? Is that okay? Well, don't just look at the 5. That's not what we're considering here. We want to know, if I put 5 in there, do I create a negative number? No. So that's okay. If I put a 5 in there, do I create a negative number? No. So 5, if that's the solution, works. But what if I had x equals 2? Will that create a problem there? No. But when I stick it in there, 2 minus 3 is 1, and the ln of negative 1 doesn't exist. So, and I'll show you that in my calculator. If I tried to do the ln of negative 1, it says there is no answer, right? You cannot use positive multiplication and division to create negative numbers. There's just no way to do it. So every time you solve a logarithm, you need to check that that solution creates only positive numbers in the original equation. Okay, so let's do one more of these. Not that one. That one's too easy. Here we go. So log base 3 of, no, x minus 3 over 10 equals log base 3 of 2. Drop the logs, times by 10. So x minus 3 equals 20. Add the 3, and I get x equals 23. What should I do with 23? Plug it in. Is 23 okay? Yes. So we're good. Okay, let's make it one step harder. Nope, there are 2 more. Oh, never mind. It is the last one. Why is this one different? The other number. Okay. Do I have a log equals a log? No, I have a log equals a log plus another number. So I cannot drop logs here. There is no way to eliminate that 1. No matter what I do, it's going to stay on one side or the other in some form. So I cannot drop logs. So what I need to do is put my 2 logarithms together. So I need to move this logarithm over here using subtraction. Okay. So on the left side, I get log 4 of x minus 5 minus log base 4 of x minus 2 is equal to 1. Now what? Well, I can't drop the logs. You can only drop logs when you have log equals log. Yeah, we're going to squish it together. So we have log base 4 of this divided by this. Right? One's positive, one's negative. Positive 1 goes on top, negative 1 goes on bottom. So x minus 5 over x minus 2 is equal to 1. And now this is the problem we were doing at the beginning of class. Now we just convert to exponent. 4 to the first equals this. So 4 equals x minus 5 over x minus 2. Okay. Now we just multiply by x minus 2. Move that to the other side. 4x minus 8 equals x minus 5. Add the 8. So x equals 1. That had a lot going on, right? Now, is 1 okay? No. If I plug 1 into those equations, I get both negative logarithms. So this one has no solution. All that work for nothing. Okay, let's do another one like that. No, I don't want to do that one yet. Okay, same idea here. I'm going to subtract the log on the right to the other side to get them together. Log base 4 of x plus 1 minus log base 4 of x minus 2 is equal to 1. Now I can squish them together. Log base 4 of x plus 1 over x minus 2 is equal to 1. Now that I have a single logarithm, I can convert to exponent. So 4 to the first is x plus 1 over x minus 2 times by x minus 2. You guys are getting the hang of this. And I get 4x minus 8 equals x plus 1. So x is 3. But I have to check that. Is 3 okay? Yeah. Yep, it works. Okay. Now, there's only one other version of this. Nope, not that. Oh. Okay, this one. Same idea, except it's not going to be a negative over here. It's going to be positive log base 5 of x minus 7. How is that different? Instead of divide, we multiply. Log base 5 of x minus 3 times x minus 7 equals 1. Yeah. So now we convert to exponent. 5 equals x squared minus 7x minus 3x becomes negative 10x. Now it's a quadratic. How do we solve quadratics? Nope. No, don't do the square. You put 0 on one side. So we get 0 equals x squared minus 10x plus 16. And then we factor. Are there two numbers that multiply to be 16 and add to be negative 10? Negative 8 and negative 2. So 8 and 2. Do those numbers work? 8 works, but 2 does not. If they both work, then you just have to separate your answers with commas. But in this case, the 2 does not work because 2 minus 3 is negative 1. One more of those. Is this going to be that same kind of problem? Nope. You're going to get a plus and a minus. So we want to do a plus and a plus. Will that one do it? Yes, it will. So the left side is going to be log base 4 of x minus 3 plus log base 4 of x minus 6 is equal to 1. So that combines to be log base 4 of x minus 3 times x minus 6 is equal to 1. Now what? 4 to the first is x squared. No. Minus 9x. And then plus 18. Subtract the 4. Are there two numbers that add to be negative 9 and multiply to be negative 14? So x minus 2 and x minus 7. So 2 and 7. The 7 works, but the 2 does not. That's it. Okay, get to work.